Fish belong in water. That's not an opinion. It's the basic rule that separates fish from every other class of animal on Earth, built into their biology at the most fundamental level. Gills instead of lungs, fins instead of legs, a body designed around buoyancy rather than gravity. Except one fish never got the memo. It can leave the water entirely, drag itself across dry land using its fins like crude legs, breathe air directly through specialized organs, and survive for days at a time without ever returning to a pond, river, or lake. This is the walking catfish, and it's rewriting what we thought a fish was even capable of. The walking catfish, native to Southeast Asia, but now found as an established invasive species across parts of Florida and other regions, gets its name from something it genuinely does. It walks. Using its rigid, spine-like pectoral fins as makeshift limbs and a side-to-side wriggling motion of its body, the walking catfish can propel itself across dry land at a surprisingly fast pace, covering distances that would be impossible for almost any other fish species. It's not swimming through shallow puddles or flopping helplessly. It's actively locomoting, using a coordinated movement pattern that lets it travel across grass, mud, and even paved surfaces in search of new water sources when its current habitat dries up or becomes overcrowded. What makes this possible is an adaptation most people don't associate with fish at all: an accessory breathing organ. The walking catfish has a specialized structure above its gills, sometimes described as a primitive lung-like organ, filled with highly vascularized tissue capable of absorbing oxygen directly from air rather than water. This means the walking catfish doesn't just tolerate being out of water the way some hardy fish species can for brief emergency periods. It can genuinely breathe air, allowing it to survive on land for extended stretches, as long as its skin remains sufficiently moist to prevent its gills and this accessory organ from drying out and losing function. Documented cases show walking catfish surviving out of water for multiple days at a time, particularly during Southeast Asia's dry season, when they emerge from drying ponds and rice paddies and travel overland, sometimes considerable distances, searching for the nearest surviving body of water. This isn't a rare, desperate last resort behavior either. It's a core part of the species' survival strategy, evolved specifically because the seasonal wetlands and rice paddies these fish call home regularly dry up completely, and a fish that couldn't leave would simply die every single dry season. Evolution solved that problem by producing a fish that treats the pond is gone as a solvable logistics problem rather than an extinction event. The walking catfish's invasive spread into Florida in the 1960s illustrates just how effective this adaptation is. Introduced through the aquarium trade, escaped or released individuals didn't just survive in isolated ponds. They spread across the state by walking between separate water bodies, something researchers initially found difficult to believe until it was directly observed and documented repeatedly. Wildlife officials have found walking catfish crossing roads, invading residential swimming pools, and turning up in bodies of water with no connecting waterway to any other population, the only explanation being that the fish walked there under its own power, sometimes traveling significant distances over land during humid nights when moisture loss was minimized. But here's where the story gets even stranger, because the walking catfish isn't actually the record holder for land survival among fish. It's just the one that does it while moving. That title belongs to the mangrove killifish, a small fish found in mangrove swamps across the Americas, which has been documented surviving completely out of water for up to 66 consecutive days. Unlike the walking catfish, the mangrove killifish doesn't wander. It hides motionless inside damp, rotting logs, sometimes in groups of dozens of individuals packed together inside a single log cavity, changing its gill structure and even its method of excreting nitrogen waste to function entirely differently on land than it does in water. Research led by biologist Scott Taylor found that mangrove killifish essentially rebuild their gill tissue while out of water, restructuring the cellular composition to handle air exposure, then reverse the process again once they return to water, an act of physiological transformation that has no clear parallel anywhere else in the fish world. Both of these fish share the same underlying evolutionary pressure. habitats that are seasonally or unpredictably unreliable, forcing a choice between developing the ability to survive without water or risking extinction every time conditions changed. And in both cases, evolution didn't just produce marginal tolerance for dry conditions, it produced genuine, functional adaptation. Air-breathing organs, restructured gill tissue, and in the walking catfish's case, an entirely new mode of locomotion that lets the animal actively search for a solution instead of simply waiting to die or be rescued by rain. This raises a question worth sitting with. How many other categories we consider fixed and absolute in the animal kingdom? Fish live in water, birds fly, mammals give live birth, are actually just the common case, with edge case exceptions quietly proving the rule wrong under the right evolutionary pressure. The walking catfish didn't evolve legs. It didn't stop being a fish. It just found a way to treat no water nearby as a temporary inconvenience rather than a death sentence, and in doing so, blurred a line that most of us assumed was absolute. So the next time you're near a pond in Southeast Asia, or an artificial waterway in Florida during a humid night after rain, and you hear something moving through the grass that shouldn't be there, it might not be a snake, and it might not be a rodent. It might be a fish, walking, on its way to find water somewhere else. Which detail surprised you more? The walking, or the fact that another fish can survive over 2 months completely out of water? Drop it in the comments, and subscribe to NatureCrest for more deep dives into the animal kingdom's most extraordinary and most misunderstood creatures.